write an answer displacement vector by using the ratio theorem. So this is n m plus what? N, and then it's multiplied by positional vector AB, and this is equation 5. So now you have 5 equations there. You have to analyze the relationship. Equation 1 relating to equation what? Equation 4. Right? Or you can find that you have different options there to go around. Because AC is also relating, mean that AC can substitute AC in this equation. Right? And then you can substitute vector A, P. So you go for the first step. The first step, we say that substitute equation 4. Where is equation 4? This one. In what? In equation 2. In equation 2. So where is equation 2? Equation 2 is vector C is equal to what? Vector C is equal to vector A plus displacement vector AC. Right? So you say resultant vector C is equal to vector A. Vector AC is M over M plus M. Then we multiply by what? Vector A, B. This will be equation 6. Right? Equation 6. And then we have equation 6. We want to eliminate this one because we know the general formula of integral divisions of a vector, it does not contain any displacement vector. It should contain only ratios and position of vector. So you have to eliminate your displacement vector AB. How do we eliminate displacement vector AB? We have to make the subject the displacement vector AB in equation 1. So that the 50th step. So 50th step, we say that to make displacement vector AB the subject. You will understand even if you don't want to understand. You know what? In equation what? In equation 2. Equation 2, equation 1. So it means that our displacement vector AB, this will be equal to what? It will be equal to resultant vector B for that equation minus vector A. So this will be our new 7th equation. Our new 7th equation. Okay, so we have our new 7th equations. Then we are about to finish. Then we go to the 6th step. We say that let us substitute equation 7 into it, into equation 6. Okay? Equation 6. So if you substitute the equation 6, you have vector C is equal to vector A plus M, M plus N, times vector AB, which now is C vector B minus vector A. Interesting. We are about to reach the destination. The 7th and last step. We say that now simplify. So this is equation 8. Right? Simplify equation 8. And then let us make vector C the subject. Okay? How do we simplify? We multiply by Mn to both sides, left hand side and right hand side. So we have vector C times M plus N. This is equal to vector A times Mn. And then if we multiply that one, we cancel. So we have plus M times vector B and vector A. Open the bracket. I told you, these are scalar now. So Mn are treated as what? Scalar quantity. And then AB is what vector? Is a vector. So if you open the bracket, or even if that from that point, you don't need to open the bracket because we want to make the, yes, we need just open the bracket on right hand side. So left hand side we just leave because we want to make n the subject. So we say that if you open the bracket, on this side we are going to have vector A. No, we have to start on writing scalar as I told you. Times vector A plus what? Scalar quantity n times vector A. You see the importance of the concept of scalar. Then you have what? Scalar quantity B times vector B minus scalar quantity n times vector A. So, is there any like terms? Yes, these are the like terms. So m scalar quantity m times a minus m times a is 0. So then we have c, this is n plus n. We remain with what? N times scalar quantity times vector a times n times vector b. So then we divide by m plus n, and then c divide by m plus n. So now, the general formula just to finalize, we said that the general formula of internal division of vector vector A and B by m ratio n is given as resultant vector C is equal to n times vector A plus what? Plus m times vector B divided by what? M plus n. So this is our general formula. Fantastic. Beautiful. So clap your hands. Congratulations. You did very well. Okay, so that is about the derivation for the internal divisions of of a line. So if you have any questions, you need to understand in all those 7 steps, let me know in the comment section. But let us go to the derivations of external, because sometimes the questions is just asking us to find the internal and external division. So you should know the formula also for the external division, and then we enjoy the beauty of basic engineering and scientific mathematics. Have you understood? I'm asking you, have you understood? If you have understood, tell me in the comment sections. If not, tell me in the comment section. I can also repeat and clarify to you. Okay, so let us proceed with our session, so lecture 4 vector. And then this is the general formulas that I have written, the general formula of internal division of a vector. Vector A and B by M and D by ratio M and L. This is the general formula. So we have to derive, just like here, we derive the formula of internal division of a vector. So you have to derive also the general formula for the external divisions of a vector. So let us go to the business. Are you ready for that? Are you ready for that? If you are ready, tell me in the comment section, please. Okay. So we go for another part. We say that another concept, excuse me, derivation or derivation of the general formula, of external division of a vector. So if we divide a vector externally how can we derive the general formula, right? That's the responsibility that we have. So we're gonna follow some steps, just like in the first case. The first step, we say that consider the general consider the representation. If you're joining me right now, you're welcome in online diploma Polytechnic Institute of Technology of Tanzania. Representation, consider the geometrical representation. Geometrical representation of position of vector A and position of vector B, right? We sort it with vector C, we can call vector C, okay? Or just to differentiate it, we see vector P that divide vector A and B externally in ratio of Mn. So we want to draw the geometrical representation. We have two position of vector. So please be serious. Look the difference between the geometrical representation of internal division of a vector and the external division of a vector. So this is y-axis, say y-axis. This is x-axis, say x-axis. This is origin, right? Positive y-axis, positive x-axis, right? And then we have our position of vector here. Okay, so you have, first of all, let us put displacement vector, draw the line for displacement vector. This is set displacement vector. And then here we have position of vector. Position of vector, just to remind you, from the concepts of terminology, which is lecture 2, I told you that position of vector means is a vector that begins at origin and end somewhere else in the plane, just like that. So suppose that okay, so here we have our three positional vectors, and also we have our displacement vector. Let us suppose that, okay, we can call the same names, we can label, but let us say, let us suppose that this is point C and this is point D, right? Listen carefully. And then suppose that this is position of vector A. So when we are dividing a vector externally, just like a line, so these are the two vectors that we are dividing, so A and vector B. So which vector is dividing? This one is dividing externally. So externally means that if, for example, we erase these lines, so these are the two positional vector, right? And then because these are the two positional vector, the external division, if the vector will divide the two vectors A and B, is this one, which we say that, we let it, this is vector P. Suppose also here we have a point E, and then the initial point of the vector is origin, and the final point is point D. So from that perspective, from that point, we have also three triangles, right? We have three triangles. But let us present the ratios, right? How do you present the ratios? Suppose that this is minimum value of the ratio, which is n from A to D, and that's because it's external division. So this means that the ratio m is the distance from C to D. So be careful on that. because even the ratio theorem is going to change a little bit. Right? So afterward, you have to enjoy basic engineering mathematics. Afterward, we have to apply what? The second step. Say that we have to recall and apply what? The triangle law. Triangle law, right? For each triangle, for each triangle. Each triangle. So let us consider the first triangle, the largest triangle, which is triangle OCD. OCD. We have three vectors there. The first one is vector A, right? So vector A and vector CD, that displacement positional, and what? And vector P. So which among these three vectors is a resultant vector? Which among these three vectors is a resultant vector? So this is the resultant vector, vector P. So then according to the triangle law, vector P will be equal to the sum of vector A plus displacement vector, which is vector CD. So this is our first equation. Right? And then we consider, so there we consider that triangle. And then we as mathematicians, we consider again triangle OCE. So this one, we have three vectors, A, vector CE, and D, vector B. This is displacement vector. So what is the resultant vector here? Vector B. So through ratio, you will understand the resultant vector and other vectors. So it means that now, the resultant vector B is equal to positional vector A plus displacement vector, which is CE, right? So this is second equation. Again, we have to consider triangle. You have to consider triangle OED. So triangle OED, it means that we say that we have what? We have two vectors, and this is the positional vector. So what do we say? We say that, okay, fine. So we say, what is the resultant vector here? This vector P. OED, vector P. OED, vector P is a resultant, positional vector, displacement vector. So again here, vector P is a resultant vector, and then the positional vector B, and then we have to plus with vector ED. So this is the third equation, right? So if that's the case, we want to eliminate all the displacement vectors and make vector P the subject as a resultant vector. So do you remember the steady step? The steady step from the previous derivation, we say that we have to recall the ratio theorem. Remember the ratio theorem which I taught you at the beginning was the ratio theorem for the internal division. Ratio theorem of what? External division. So I will give you here because we need the theorem division. If you try to think yourself, how can you give it? Okay. So for that case, you'll find that we have only one ratio theorem for this scenario. This N is from E to D, this M is from C to D. Before, if you do remember that, we said, for example, for that case, we say that vector E, right? Vector E and vector E in terms of ratio theorem, was it what? Vector what? Let me check. PQ. For instance, that we say, in case for the external division, vector CE, it was what? We had the m plus n. Then times what? The resultant vector, which is c, d, just like this. But in this case, remember that m was a ratio representing CE, and also n was a ratio representing ED. For this case, now it has changed. M representing CD, so it means that it's equal to the sum of the ratios. So that's why, so this is 40 internal division, as I told you. Internal divisions of 40, internal divisions of the vector, right? So if that's the case for the external division, what do you say about external division? For the external divisions, so this is all about what I just wanted to recall. For the external division, we say that vector ED, right, is equal to what? N over sum, but sum today it is M. And then so what the resultant vector? Resultant vector is CD. This is concept. I haven't had this one, so keep it. Don't round like this in the exam. Just counting to give you notifications. Okay? And then, so it's NP over, yeah. So by using only this one, we can deduce now our general formula. How? Because we say that this is fourth equation. we have first equation taken, and so then what can we eliminate? We can eliminate, we can substitute equation 4 into equation 3, right? Can substitute so that the force is stable, right? Remember, this is only for external division. For external divisions of 40 of a vector. For internal, consider that ones. The first step, we say that let us substitute let us substitute equation 4 in equation 3. Equation 4 in equation 3. Equation 3 begins with positional vector P is equal to positional vector B plus what? ED. What is ED? It is N over M. And then multiplied by what? Vector C, D. So this will make what? We make the fifth equation. Again, we want to eliminate this what? This positional vector, now this displacement vector. So you have to use what? The first equation. So we say that the fifth step make what? Make CD, displacement vector CD, the subject in equation what? In equation 1. In equation 1. So it means that displacement vector CD is equal to resultant vector P minus what? Minus positional vector A. So this will make the sixth equation. So then we go for what? For the sixth step. The sixth step, we say that, okay, so now we have, it means the relationship between equation 5 and equation 6, we say that substitute, see the way that I simplify my teaching, okay, substitute equation 6 in what? In equation 5. So this is vector P is equal to vector B plus what? And M. And then we say that vector CD, it is what? It is vector P minus what? Vector R. okay, vector R, right? That is. So then we say that the next step, we have now positional vector and ratio values. So we go for the 7th step. We say that simplify, suppose that this is question not 7. Let us simplify question 7, right? And what? And make resultant vector P, which is a vector, a positional vector that dividing vector AB, okay, the subject, right? So that is good news. So P is equal to what? Is equal to vector B plus what? N over N, and then we say that we have P minus A. So we multiply by M both sides, right? By M. So we have M positional vector B is equal to M, which M now is the scalar quantity, okay? And then this M and this M will cancel. So we say that plus N, then we have positional vector B minus A. So if you open the bracket, we have scalar quantity B times vector B plus what? N times what? Vector P, and then minus what? Minus N positional vector A. So next we have to make P the subject. We have positional vector P. So we have to bring this on this side. So we have scalar quantity M, positional vector P, and then this one, this is equal to what? Is equal to M, positional vector B, minus what? N, positional vector Q. Then make this one the subject. M minus N is equal to M, B, N, positional vector A, right? And then M minus N, right? So we say that we have positional vector P is equal to what? M, B minus M, A over M minus N. So this is the general formula of resultant of a vector, or find the general formula that help us to find a vector which divide two positional vector external. So it might be B, it might be N times B, or some of the books they can write these formulas. P is equal to N times positional vector A minus N times positional vector B, but even denominator is N minus N. So what happens in these two formulas, it means that we just multiply by negative. So this becomes positive, negative. That is, okay? So have you enjoyed? Did you understand how derive? Can you derive yourself? Can you stop the video? And then take a piece of paper and try to derive yourself if you reach there, right? And tell me in the comment sections, I'll be happy. Because now you are gaining, because I'm delivering what I know to you, and you have to make sure that what I give you become yours. Okay, let us continue with the beauty of basic engineering and scientific mathematics. Okay? Basic engineering mathematics, and so I have a question here, and then I'll leave homework for you. We did it was example 7. So we did example 6, so this will be example 7, right? Example 7. So the question will say that if A is a point, if A is a point, is component 3, 1, negative 2, and B is a point which has components 1, negative 3, 1. Then we have what? A, find, right? Find the position vector. Find the position vector dividing vector AB. Dividing vector AB. Okay, get vector AB internally. Right? Internally in ratio of 2 to 3. Then we go for B. Find position vector dividing AB externally in the ratio of 5, ratio 4. Okay. So we have one question but with two parts, part A and part B. And the good thing, part A is all talking about internal division of a vector, and part B is all talking about external division of a vector. So if I teach you that example, then nothing new about the internal and the external division for basic engineering and scientific mathematics. If you are doing advanced mathematics, at least that you have to think beyond of what beyond of these examples, because sometimes the vector questions they might be even in a different way. So you say that if A is the point 3, 1, negative 2, and B is the point 1, negative 3, 1, find the positional vector dividing vector AB internally in ratio 2, 3. And find the positional vector dividing AB externally in this ratio. So solution. So we'll be given sort. So these are the points, right? So the first step, we'll be given those points. We say that, let us use those points to mean that we say deduce positional vector, right? Positional vectors due to the given points, okay? Such as, so we say that such as, you can call them vector A and vector B. So that those are positional vector because they are, to reach to 3, you have to move from 0, or when x is equal to 0, you reach to the point 3. For 1, similarly, and for negative 2 also is the same thing. So we say that vector A now, which is equivalent to positional vector OA, in case that maybe you get confused, you can say the vector OA. This will be 3i, because this is dimensional, and then you say minus 3j, then plus what? Plus k. Right? And then we have another positional vector, which is positional vector OB. This we can let it be just to simplify, okay? For those who does not like mathematics, excuse me, this is plus j minus 2. Thank you, God. I not say a mistake I made. 3i plus j minus 2k. And then the other one is I minus 3j, okay, minus 3j, and then plus what? Plus k. So the ratios, that it means m, ratio n, this is equal to what? 2 ratio 3. I have to say m is equal to 2, n is equal to 3. Right? Okay, that's the first step. So you go for the second step. Go for the second step. The second step now, we say that recall the general. Remember here we are solving for part A. General formula of finding the vector that divides vector A and B by ratio Mn. So from the formula we say, suppose the resultant formula is vector C, then we have M multiplied by vector B plus N multiplied by vector A divided by summations of ratios. Okay? Summation of ratios. I believe that the formula, yes, that is. So the next thing is just you substitute. What the value of M? M is 2. What the value of B? It's I minus what? What minus? It's 3I. 3I plus J minus 2K. Then plus N. N is 3. Oh, excuse me. This is common mistake that I made. I have to take the value of M, which is 2, and then vector B. What is vector B? What is vector B? Vector B, it's I minus 3J. No, yes, minus 3J, yes, plus K. Is that there? Yeah. 1, negative 3, 1. This is the common mistake that you can do on exchanging the vectors. Then we take n as a scalar quantity. Vector A, it is 3i, and then minus 3j. Then plus what? K. Divided by sum of the ratios, which is 2 plus what? 3. The answer, vector C is equal to 2 times I, it is twice I. 2 times this one is negative 6j. Then 2 times k, it is twice k. Then plus 3 times 3, it is 9i. And then 3 times 3, it is 9j. Okay? 3 times this one is 3, what is 3k? 2 plus this one is what? It is 5. Then we add the components. 2 plus 9 is 11i. This one is minus 15j. This one is plus what? 5k divided by what? By 5. Right? So this will make what? This will make 11 over 5i. 15 over 5 is 3j. 5 over 5 is 1. So our resultant vector will be like that ones. And also you can write in form of the point. It's a positional vector. Find the positional vector that divides that lines externally. So therefore, we say that the conclusion, the positional vector C or C, if you want to write in this form, okay, is what? 11i minus 3j plus k, right? or this one in other words, you can write in terms of point. 11 over 5 negative 3 1. So this is the final response. Right? Have you enjoyed? Let me know in the comment section. Then let us solve part B. In part B, we say that find position vector dividing AB external length ratio 40 MA. Right? Dividing displacement vector AB in ratio 40, 5 and 4. So we have A, right? That is value of M and N. Okay? So we have value of M and what? And N. Those are our positional vectors. So it depends. You can use any language that we want. Let me advance you right now. Let us use this positional vectors, this notation positional vector, or A. So it is 3 what? It is 3I, then plus J minus 2K. Am I right? Yes. And then positional vector OB, this is equal to what? This is equal to I minus 3J and then plus what? K. But our ratios today it is M ratio N, always. M start and then next is N. So this is equal to 5 ratio 4. You should keep in your mind. Even in alphabetical order, we say M, N, O. So M starts. So the first value in ratio is M, and the second value is N. Don't confuse, keep it that in your mind. So then we are looking forward for vector OC, which is positional vector. So this is what required. So suppose that this is the first step. Those are the data given. So the second step says that you have to recall what the general formula. General formula of finding what? Of finding a vector, okay, that divides another vector, let's say AB external. Soon I have taught you how to derive. We say that suppose we used to call it vector P, but for our case, vector P it is vector OC. This is equal to what? M times vector, not M times vector B. We counter check. Yes, M times vector B minus N times vector A divided by M minus N. It's simple to remember these two formulas. If you remember the general formula of finding a vector that dividing two positional vector or a displacement vector, because divide sort of displacement vector AB, for example, is, if you remember it, this one, then you know what happens in case of, for internal, this is internal. For external, you just eliminate the positive with minus, and then here with minus. That's what we did here. Simple like that. That's why I told you that in our online schools, we simplify stuff. So then now we say positional vector OC, which divides displacement vector AB, is equal to what is M? But today M has been changed, is 5, right? So this factor M is equal to 5, and N is equal to 4, just to eliminate the confusion. What is vector B? So in the other way, this formula you can write at M times positional vector OB minus N positional vector OA divided by what? A minus N. So you have 5. 5, what is vector OA? It is 3I, it is J minus 2K, right? And then you say minus N. What is N? N is 4, right? 4 times A. 8 is what? This is vector A. I made a mistake. I told you this is the common. You have to be careful. In exam, you have to be very careful. You have to say J. This is common mistake that I've been making to show you that you can do a mistake. Minus 4. Minus 4, then we have vector A. Vector A is what? 3I minus what? Not minus, plus J minus 2k. And then divide by 5 minus 4. So positional vector OC, 5 times I, 5i, minus 12i. Right? The answer is minus 7i. Then 5 times negative 3j, it is negative 15j to minus 4. So negative 15 minus 4j is equal to negative 19j. Okay? Then 5 times k is 5k plus 8. 5k plus 8, this makes 18k. Then for the denominator, 5 minus 4, it is 1. So all of this one divided by 1. So we have found a positional vector dividing a line or dividing a displacement vector AB in ratio of 5 to 4. So then this is said that therefore the positional vector that divides vector AB is negative 7i, then minus 19k, then plus 13k. That's the response. Okay, so I believe that you'll be solving the questions of 40 of internal and external divisions of the line like that. You'll be solving many of those questions without any fear. So now it's time for the homework. You have to make sure that you do this homework before you take lecture 5. So this is homework 4. We name homeworks according to session number, right? So you have to make sure that you take this homework before lecture 4. Okay, so this homework has 2 parts, A and B. So A state that let positional vector A, B, and C to be positional vector, to be positional vectors, A of point A, point B, and D, point C, right? Whereby point A has coordinates of negative 3, 2. Point B has coordinates of 4, 5. And D, point C has 2, 2. Find the displacement vector. Find the displacement vector AB, displacement vector AB, and the position vector. And the position vector of the point P. Of the point P that internally divides vector B, C in the ratio of 3 to 4. Then B is testing you about the concept we covered in lecture 3. Find the unity vector. Unity vector of position of vector A, very simple. The simplest equation. You get the 3I plus what? 4J. So do that homework and then make sure that you submit it. Where will you submit? I told you in the introductions that you will submit your homeworks in the comments sections. So you have to go to the comments and then write in your solutions. Like the way that you have to write, you have to learn to do mathematical questions by following steps, because even if that you want to solve a real world problems, there are some steps that you have to make sure that you follow. So we are teaching you how to work systematically and sequentially. Meaning that from one step to another step while you understand. But also it is simplify when you be doing a quick review later on, you understand that what has been done in that step. So I thank God who gave me a gift of teaching and built a teaching in me. I thank God who has given me this idea and given me power and preparing me. I give him all the glory and praise for everything that I have done. And I thank him also who has given me strength to teach and understanding and the language to speak to you. However, that my voice is not good, but don't worry about that. The Lord is still working. And I thank you. I thank God for you who is watching me right now. And I thank God also you have taken your time and learn with me from the beginnings to the end. May God bless you abundantly. I'll let you invite you in lecture 5 of vectors for the ordinary diploma engineering and scientific students. So make sure that you meet there. There's a lot of things that we're gonna cover. And make sure you do the homework. In case that you find any challenge for question number 4A, you have to, but this is question number 4A, but in terms of sequence of examples, this is example 7, right? So you can make sure that you ask your questions along the video, repeat the video several times as you can, make sure that you follow the primary steps that I told you to take, and let us meet in the 5th lecture of vectors. And then, yeah, please, I insist you that pray for me. It's a heavier duty that I'm doing, and it's a huge project that I'm doing. And then I will also pray for you, because even yourself, you want to solve complex problems. So thank you very much. May God bless you abundantly. I would like to meet you in the next session. OLENJOLAI loves you. May God bless you.